Traditional RAG finds answers in your documents. But what happens when the answer doesn't live in any single document? That's where GraphRAG comes in, and it changes everything. Quick recap. Traditional RAG, retrieval augmented generation, works like this. You take your documents, break them into chunks, convert them into vectors, and store them in a database. When a user asks a question, the system finds the chunks with the most similar meaning and feeds them to the language model. It's like giving the AI an open book exam. And for direct, factual questions, it works great. But here's where it falls apart. Imagine you have 10,000 documents and you ask, what are the main themes across our customer feedback this quarter? Traditional RAG finds the 5 or 10 chunks most similar to your query. But the real answer requires understanding patterns across hundreds of entries. Or consider this: which executives at company A have connections to board members at company B? That answer is scattered across dozens of documents, connected by relationships that vector similarity alone cannot capture. Traditional RAG gives you local relevance. It finds nearby pieces, but it completely misses the global picture. GraphRAG adds a knowledge graph layer on top of retrieval. During indexing, an LLM reads each chunk and extracts entities, people, companies, concepts, and the relationships between them. These become nodes and edges in a knowledge graph. Claude, developed by Anthropic, that's a directed edge. Then community detection algorithms group tightly connected entities into clusters. A cluster of security concepts forms one community. A cluster of AI frameworks forms another. Finally, the system generates natural language summaries for each community, capturing the themes and relationships within each cluster. This is the secret weapon. GraphRAG gives you two ways to search. Local search is like traditional RAG but graph-enhanced. Find relevant entities, traverse their relationships, and gather connected context from multiple documents. It follows the thread. Global search is the real game changer. Instead of searching individual chunks, it reads across community summaries to answer high-level questions. No single chunk needs to contain the full answer. The system synthesizes understanding from the structure of your entire knowledge base. This is why GraphRAG outperforms traditional RAG by 30 to 70% on questions that require connecting dots. So when do you use which? Simple rule: if the answer lives in a single passage, traditional RAG wins. What's our refund policy? Traditional RAG. Find the definition of a term? Traditional RAG. It's fast, cheap, and effective. But if you need to connect information across multiple documents, summarize themes across 500 tickets, trace dependency chains, find relationships between people or systems, GraphRAG is your answer. The smartest teams use both. A routing layer analyzes each query and decides which strategy to use. Local factual questions go to vector search. Global analytical questions go to graph search. There's a catch. GraphRAG is significantly more expensive. Indexing takes hours instead of minutes because every chunk requires LLM calls for entity extraction. You need a graph database on top of your vector database. Query latency jumps from milliseconds to seconds. But for the questions that matter most, the ones traditional RAG simply cannot answer, the quality improvement makes it worth every penny. That's GraphRAG versus traditional RAG. The key insight: vector search finds similar pieces, graph search finds connected knowledge. Check our blog for the full deep dive with code examples. Link in the description. Subscribe for daily AI engineering content. Next up, we're building a complete RAG application from scratch, step by step.